Hi everyone, today we're going to take another look at scatterplots and sort of see how we can use the information even though we don't have an equation or an exact relationship. We can still take a look at the data. So example number 1 shows the lengths and widths of 12 birds. So as the length of the bird on the x-axis, what happens to the wing spread of the bird on the y-axis? So just generally looking at our data, we notice that our points are rising to the right, and that means that, so our points are rising to the right, and we also notice that, when we're talking about the relationship between variables, we talk about as the variable on the x-axis increases, so as the length of the birds increase, what happens to the wing spread? Well, we notice from our graph that our wing spread is also increasing. Okay, so the scatter plot shows this relationship. Again, same thing as A. The points are rising to the right. And if we think about our equations, or our linear equations in particular, that means that we have a positive slope. Now, we don't have an exact value here, but we still have a positive correlation between the data because as one increases, so does the other. Now, if we want to estimate the length of the bird with a wing spread of close to 220 centimeters, we take a look at 220 on our y-axis, and we don't have a line, so we're just going to estimate. We're going to go over here right in the middle of all the points that are happening and look in general. So if we follow this down, we notice that our blocks are 25 every 2 blocks, 25 centimeters. So what we can do is just say that it's about 120 to 125 centimeters approximately. Okay, we don't know that that's exact. There's no formula that's going to tell us exactly, but we can still estimate. The next one, if we are going to estimate the wing spread of the birds that are about 50 centimeters long. So again, we're going to follow right into the middle of our data and follow over to the y. So we know that it's going to be approximately 100 centimeters. Okay, so even though we don't have an exact relationship and an equation that tells us, we can still use the data that we have to take a look at the trends that are happening. Next, we have teachers recording how many days of school students have missed and their mark. So setting up our axes, we notice that they were already kind of there, but we want to make sure they're nice and dark, that we know exactly what we have on each axis. So our first item in any table of values goes on our x-axis. So number of days missed. And that means that mark in percentage is going to go on our y-axis or our vertical axis. So we notice that we need to go up to at least 12 days of school. So we do have enough blocks that we can go by ones. And we don't necessarily have to label every single one of them. So we're going to measure or label every fifth one. As far as mark, notice that we don't start until 67. So 0 to kind of 60 is a waste of space on our graph that doesn't really give us any information. So we put our little lightning bolt or our squiggly at the beginning here to show that we have skipped some of the data on the y-axis that was irrelevant. And what we're going to do is start at 60, and we're going to label, we need to go to at least 95, so we may as well go to 100, and we're going to go every 3 blocks is 10%. we want to spread out the data a little bit without running out of room. So now we're going to plot our points. 3 and 86, 8, and sorry, 86 is up here, 8 and 74, 4 and 83, 0 and 95, and 12 and 67. Okay, so we have our points, and we notice that our points are falling to the right. Now the relationship between our attendance and marks, again, as number of days missed increases, the mark decreases. And again, that's in general. So remember, when we have points or a line, when we talked about linear equations, we falling to the right means that we have a negative slope. Well, this means that we have a negative correlation. So as our number of days missed increases, mark decreases, which makes it a negative correlation. They are related negatively. Now, we can also do this using Desmos, just like we did last day. So, taking a look at Desmos. Now, I've already put my points in here. Remember, we find our table at the top here with our plus sign. Click on table to enter our data. Now, we notice as well that we need to change our axis. So, again, our wrench. And we're going to input the same values that we did for our actual graph. So 0 to 15. Remember, we want to go a little bit above where our highest values are. We can also label our x-axis. So in this case, it's number of days missed. And our y-axis, we're going to again start at 60 to 100. And our label for this one is mark in percent. Okay, and again, we have our graph, we have our labels, and we can see sort of the trend of the data that as number of days missed increases, our mark is decreasing. So just to finish off here, we know that if our points nearly form a line, there is a strong correlation. So those variables are related very closely. If points are enclosed in an oval, but not almost a straight line, the correlation is weak. And if the points are in a circle that there is no pattern that we can determine, there is no correlation. Okay, so our first example, the wing spread, there is a correlation. It's fairly strong, but getting weaker. Whereas our marks, there is a sort of thinner oval that we can draw around them. So it's a stronger relationship between those variables. Now, if the points rise to the right, the correlation is positive. And if they fall to the right, it's a negative correlation. They are related, but